Welcome to Astronomy Daily, your daily dive into the cosmos. I'm Anna, and today we're starting close to home, looking at Europe's ambitious push to achieve greater independence in space, with new launch sites emerging in the Nordic region. Then we'll turn our gaze to the night sky, as July promises a spectacular show with 3 major meteor showers about to light things up. Later in the program, we'll delve into a curious case of a retracted cosmic discovery that highlights the rigorous nature of scientific investigation. And finally, we'll journey to the far side of the moon to learn about an ambitious mission designed to peer back into the universe's dark ages. So, settle in as we launch into today's astronomical headlines. Europe is currently embarking on an ambitious journey to reduce its reliance on U.S. space capabilities, a move significantly spurred by recent geopolitical events. The America First policies, coupled with the ongoing conflict in Ukraine, have underscored the urgent need for Europe to bolster its independent capabilities, not just in defense, but crucially, in space operations. The concern, for instance, that a figure like Elon Musk might limit Ukraine's access to vital Starlink satellite communications has only heightened the urgency for Europe to cultivate its own alternatives. The statistics highlight the challenge. In 2024, the U.S. conducted a staggering 154 launches into orbit, while Europe managed just 3. And out of $143 billion in global public investment in space ventures last year, Europe accounted for only 10%. With the trend moving towards lower Earth orbit satellites, which are cheaper but require deployment in larger numbers, the pressure is on. A Goldman Sachs report even estimates a 10-fold increase in LEO satellite launches in the next 5 years, potentially reaching 70,000. As European Commissioner for Defense and Space Andrius Kubilius put it, Europe needs its own autonomous launching possibilities. Currently, Europe's only spaceport is located in French Guiana, some 7,000 kilometers from Paris. While their new Ariane 6 rocket, launched earlier this year, can carry a bigger payload than SpaceX's Falcon 9, it's not reusable and comes with a higher cost per launch. This is where the budding Nordic spaceports in Sweden and Norway come into play, offering Europe a rare advantage. Take the Esrange Space Center in Sweden, situated 200 kilometers above the Arctic Circle. It boasts an expansive 5,200 square kilometers of uninhabited land, making it ideal for recovering rocket parts. This unique feature, combined with its proximity to railways and an airport in Kiruna, gives it a significant edge. Esrange, which has been operational since 1964 for research rockets, was inaugurated as mainland Europe's first orbital launch site in 2023. Preparations are well underway, with new launch pads and facilities being readied. Esrange has strategically opted for existing hardware, signing contracts with U.S. rocket manufacturer Firefly and South Korea's Perseids, giving it multiple launch options. Firefly, for instance, plans to launch from Esrange from 2026 and offers a rapid response service, potentially sending rockets into space within 24 hours to meet urgent needs, like replacing a failing satellite. Then there's the Andøya Spaceport, an island base in northern Norway. In March, Andøya successfully conducted the first test launch of a small rocket from German startup ISAR Aerospace. While it only flew for 30 seconds before falling into the sea, it was deemed a success and points towards future capabilities. ISAR is aiming for its first commercial flights next year, and its CEO, Daniel Metzler, highlighted the enormous interest from defense ministries, even before a successful orbital launch. He noted that the renewed focus on European defense was significantly driven by geopolitical shifts. Both Esrange and Andøya are seen as Europe's best hope for securing independent access to space in the coming years. While these Nordic ventures are still in their early stages compared to established leaders like SpaceX with its reusable rockets and lower costs, they represent a critical step towards Europe's space autonomy. The goal is to have all technical systems in place and thoroughly tested, with Esrange expecting to have its entire base ready within about a year. The timeline is aggressive, but the determination to achieve independent space capabilities is clear. Now let's shift our gaze from Earth's orbital ambitions to the celestial wonders unfolding above us. The second half of July and the early days of August are shaping up to be a spectacular time to step outside and marvel at the night sky. That's because 3 of the year's most captivating meteor showers are about to peak, each with its own unique characteristics. For those in the northern hemisphere, the warm summer temperatures make meteor spotting a perfect evening activity. While down south, longer nights offer extended viewing opportunities. You won't need any specialized equipment to enjoy these cosmic displays, though for some, binoculars might just enhance the experience. Meteor showers occur when our planet, on its annual journey around the sun, passes through the trails of debris left behind by comets or asteroids. As these celestial objects orbit, they shed material that remains along Earth's orbital path. When our planet enters this cloud of detritus, tiny pieces of rock and dust smack into Earth's atmosphere, burning up due to the intense friction. This creates those luminous trails or fireballs that we can see with the naked eye. First up, making their appearance around July 12th and peaking from July 29th to 30th, are the Alpha Capricornids. These meteors are visible in both northern and southern skies. They originate from a short-period comet named 169/NEAT, which orbits the sun once every 4.2 years, and their radiant point, or the spot they appear to emerge from, is in the constellation Capricorn. While the Alpha Capricornids aren't known for their sheer numbers, producing only about 5 meteors per hour at their peak, what they lack in quantity, they more than make up for in brilliance. These meteors shine exceptionally brightly, often producing stunning fireballs that can even cut through light pollution. This year, the peak coincides with a low illumination waxing crescent moon, further increasing their visibility. The best time to catch these bright beauties will be in the evening, starting around 10 p.m. local time. Next, the famous and much anticipated Perseids begin to appear around July 17th, reaching their peak from August 12th to 13th. Primarily a northern hemisphere treat, the Perseids originate from Comet Swift-Tuttle, a short-period comet with a longer orbital period of 133 years. Their radiant is located near the constellations of Perseus, Cassiopeia, and Camelopardalis. The Perseids are known for being prolific, often showering the sky with numerous meteors. While this year's peak might be a bit complicated by a waxing gibbous moon, the shower will remain active throughout the entire month of August, offering plenty of chances to catch them. Your best bet for viewing the Perseids is in the early morning hours, between midnight and dawn. Finally, we have the Southern Delta Aquariids, which start on July 18th and also peak from July 29th to 30th, sharing the stage with the Alpha Capricornids. These meteors are believed to come from the short-period comet 96P/Machholtz, orbiting the sun every 5.27 years, with a radiant point in the constellation Aquarius. This shower produces a respectable 20 to 25 meteors per hour during its 48-hour peak window. They tend to be a bit fainter and don't leave strong trails, so if you have binoculars, they might come in handy. Fortunately, this year's peak occurs during a waxing crescent moon that sets before the radiant is high, providing pretty optimal viewing conditions, especially between midnight and dawn. Keep an extra eye out for the Southern Delta Aquariids this year, as on 2 past occasions. In 1977 and 2003, they put on a much stronger show than usual, so there's always a chance for a surprise. To make the most of your meteor shower viewing experience, consider downloading a sky-watching app like Starwalk to help you locate the constellations and plan your viewing times. And don't forget to pack all the creature comforts: a comfy blanket, some snacks, and perhaps a camera if you're hoping to capture the moment. Happy sky gazing! From dazzling meteor showers, we now turn our attention to another fascinating corner of astrophysics, where a recent development has sent ripples through the scientific community. Astronomers have been captivated by fast radio bursts, or FRBs, mysterious millisecond-long explosive events believed to originate from highly magnetized neutron stars in distant galaxies. One particular event, dubbed FRB 2019-1221A, detected in 2019 by the CHIME radio telescope, initially seemed to be a groundbreaking discovery. This burst was unusual. 3 seconds long with 9 regular subbursts every 217 milliseconds. This rhythmic pulsing strongly suggested a neutron star origin, like a pulsar. Its significant signal dispersion, indicating intervening matter, led the team to conclude it came from 3 billion light-years away. For a pulsar to be seen at such a distance, it would need incredible luminosity, leading to the exciting conclusion that this was the first regularly pulsing FRB ever observed. However, the claim about FRB 2019-1221A has now been officially retracted. The Discovery team announced that a critical calibration problem in the CHIME telescope had led to a 20-degree error in pinpointing the burst's true location. CHIME is a unique instrument where sky position is electronically derived, requiring precise daily calibration. The error was attributed to an extremely rare confluence of circumstances, including heavy rain and strong local radio interference. With the correct sky position, it became clear the signal was not from a far-off galaxy, but from a familiar pulsar within our Milky Way, PSR J0248 plus 6021 in Cassiopeia. This closer location means the observed signal dispersion is fully attributed to interstellar matter within our galaxy. While a retraction might seem like a setback, the scientific community lauded the team's transparency. As one scientist noted, correcting your errors helps the science go forward. It's a powerful example of science's self-correcting nature, turning challenges into learning opportunities. From correcting our understanding of distant bursts, let's now journey to the far side of the moon, where scientists are proposing an ambitious mission to unravel the universe's earliest secrets. For decades, astronomers have yearned to observe cosmic dawn, the period roughly 50 million to 1 billion years after the Big Bang, marking the formation of the very first galaxies. Understanding these nascent galaxies is fundamental to comprehending cosmic evolution, including the roles of dark matter and dark energy. The challenge lies in observing the preceding cosmic dark ages, when the universe was predominantly filled with neutral hydrogen. The light from this period is so redshifted that it's only visible in the radio spectrum, making it incredibly difficult to detect with modern instruments on Earth due to overwhelming background noise and radio frequency interference. This is precisely why the Royal Astronomical Society is proposing the CosmoCube mission to the far side of the moon. The moon's far side offers a uniquely quiet radio environment shielded from Earth's interference. As Dr. Eloy de Lara Acedo, who presented the proposal, vividly put it, it's like trying to hear that whisper while a loud concert is playing next door. To detect the faint radio signal from the universe's primordial hydrogen, silence is key. CosmoCube will be a small satellite with a precision-calibrated radiometer operating at low frequencies. This will allow it to pick up extremely faint radio signals that have traveled over 13 billion years to reach us. Such observations could unlock answers to profound cosmological mysteries, from the perplexing Hubble tension to narrowing the search for the elusive dark matter particle. The mission aims to help us understand how our universe transformed from a simple dark state into the complex, star-filled cosmos we see today. Developed by a UK-led international consortium, the CosmoCube project team is already creating and testing functioning prototypes. The ambitious vision is for the mission to be ready to launch in 4 to 5 years, with the ultimate goal of reaching lunar orbit before the end of the decade, poised to listen to that ancient whisper from the cosmos. And that brings us to the end of another journey through the cosmos on Astronomy Daily. Today, we've explored Europe's ambitious strides towards space independence with new Nordic launch sites poised to reshape the global space landscape. We then looked skyward to prepare for July's spectacular meteor showers, offering a guide to catching those dazzling Alpha Capricornids, Southern Delta Aquariids, and the ever-popular Perseids. We also delved into the intriguing story of a retracted fast radio burst discovery, a testament to the rigorous, self-correcting nature of science. And finally, we soared to the far side of the moon, envisioning the CosmoCube mission and its quest to listen to the universe's earliest whispers, potentially unlocking secrets of the cosmic dark ages and dark matter. Thank you for tuning in and joining me, Anna, on this episode of Astronomy Daily. If you'd like to dive deeper into these stories or catch up on past episodes, visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter and find all our back episodes. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts so you never miss an update. Until next time, keep looking up.